So in this video we are going to discuss integration 2 marks. The question is evaluate integral 1 by x into log x dx. How to integrate the given function? Now in the first method, let I is equal to, I am taking integral 1 by x into log x dx. This is also can be solved by using the substitution method. So put log x is equal to t. So now differentiate with respect to x on both sides. We get, so d by dx of log x is equal to dt by dx. So now we know that the derivative of log x, what is the derivative of log x here? We know that the derivative of log x, so which is equal to 1 by x. Derivative of log x is 1 by x. So that's why which can be written as 1 by x, which is equal to dt by dx. By the cross multiplication, it can be written as 1 by x into dx is equal to dt. So now what is the given integral here? So the given integral is, therefore I is equal to integral 1 by x into log x dx. So which is also can be written as I is equal to integral 1 by x into 1 by log x dx. See, observe here 1 by x dx is replaced by this 1 by x and dx is replaced by dt. So integral, so 1 by log x is replaced by t. So that's why 1 by t, and 1 by x dx can be replaced by dt. So now I is equal to 1 by t dt. So we know that integral 1 by x dx we have seen in the other problems also. So log mod x plus c, so which is also can be written as I is equal to, so 1 by t is nothing but log mod t plus c, and also now t is replaced by what we have taken t here, so that is it, so log x, so that's why log of log x, so plus c, which is the integral of the given function. Here t we have taken log x, so that's why log of log x plus. So simply we can solve this problem by another way, another method. So what is given here? So let I is equal to integral 1 by x into log x dx, which is given. So simply we can write it as integral. So this can be written as 1 by x by log x. 1 by x by log x. So now if you take here, so let f of x is equal to this log x. So already we know that the derivative of log x is what here? 1 by x. So that's why, so if you differentiate, we get f dash x is equal to 1 by x. So what we can observe here, so we have one formula here which is in the form of integral f dash x by f of x dx, so which can be written as log mod f of x plus c. So as per this formula, it can be written as I is equal to, what is f of x? Log x is f of x. So what is f dash x? 1 by x is f dash x. So that's why I is equal to log mod f of x, that is log mod log x plus c. So like this also in other method we can find the integral of the given function. So in this we are going to discuss integration 2 marks question. Evaluate integral e power x by e power x plus 1 dx. So how to integrate this given function? So now take, let I is equal to, so integral e power x by e power x plus 1 dx. Now by substitution method we can find the integral of the given function. So put e power x plus 1 is equal to t. Put e power x plus 1 is equal to t. Differentiate with respect to x on both sides. So we get d by dx of e power x plus 1, which is equal to dt by dx. Now we know that the derivative of e power x. So we know that the derivative of e power x, so which is equal to e power x, and derivative of a constant with respect to x here, which is constant 1. So derivative of a constant is 0. So that's why the derivative of e power x is here e power x, so is equal to dt by dx. So by the cross multiplication we get here, so e power x dx, so is equal to dt. By the cross multiplication we get e power x dx is equal to dt. Now what is the given integral we have here? So therefore I am taking given integral I is equal to integral e power x by e power x plus 1 dx. So I is equal to integral, see observe here, e power x plus 1 we have in the denominator, that is I have taken t, and e power x dx, finally we get e power x dx, so which is replaced by dt. So that's why here it can also be written as 1 by e power x plus 1 into e power x dx. So from this you can understand easily. So e power x dx is replaced by here, which is replaced by, so dt, so which is equal to integral 1 by, so e power x plus 1, so which is replaced by t. So finally we get I is equal to integral 1 by t dt. So we know the integral of 1 by x dx. We know the integral of 1 by x dx, so which is equal to log mod x plus c. We have seen in other problems also. So that's why here we have I is equal to integral 1 by t dt, so which can be written as log mod t plus c. So that's why I is equal to log mod t is replaced by what we have taken t here, e power x plus 1. So that's why log mod e power x plus 1 plus c, so which is the integral of the given function. So in this we are going to discuss integration 2 marks. Question is evaluate integral 1 by x into log x into log of log x dx. So how to integrate the given function? So let I is equal to integral 1 by x into log x into log of log x dx, into log of log x dx. So now take the substitution here, put log of log x is equal to t. Log of log x is equal to t, differentiating with respect to x on both sides, we get, so d by dx of log x, d by dx of log x, so is equal to, so dt by dx. See observe here, this log of log x is like log x. Here x is nothing but again log x. So that's why we know that the derivative of log x, so d by dx of log x, so which is equal to, we know that 1 by x. So that's why here this log of log x is like log x. In place of x we have log x here. So that's why we can write first 1 by x means 1 by log x, 1 by log x into again derivative of here d by dx of this log x also. So d by dx of log x, so which is equal to dt by dx. Now again here this implies 1 by log x into, so derivative of log x is, we know that 1 by x, so which is equal to, so dt by dx. So finally what we can write here, so this implies 1 by x into log x, this is 1 by x into log x, so which is equal to, so here dt by dx, 1 by x into log x is equal to dt by dx. So from this, by the cross multiplication, we get, see here, by the cross multiplication, 1 by x into log x into dx is equal to dt we can write. So that's why in the given integral, in the given function, wherever 1 by x into log x dx is there, that we can replace by dt, and here log of log x is replaced by t. So that's why, therefore, now I am taking the given integral I is equal to integral 1 by x into log x into log of log x into log of log x into dx. So now which is equal to integral 1 by x into log x into dx. See here, in other words, we can write 1 by x into log x into, which is also can be written as 1 by log of log x dx. See, observe here, 1 by x into log x dx is replaced by dt here. So now this 1 by x into log x, so into dx is replaced by dt. So integral 1 by this log of log x is already we have taken t, so that's why this is 1 by t, and 1 by x into log x dx is replaced by dt. So again we get the function in the form of integral 1 by t dt. So we know that integral of 1 by x dx, which is equal to, so log mod x plus c. We know the integral of 1 by x. So same like that, 1 by t is also can be written as a log t, log mod t plus c. So therefore I is equal to log mod. So this t is replaced by t. What we have taken here, log of log x. So that's why log mod log of log x plus c. So which is the integral of the given function. So in this video we are going to discuss integration, 2 marks, pyqs. The question is, evaluate integral 2x plus 1 by x square plus x plus 1 dx. The solution, let I is equal to integral 2x plus 1 by x square plus x plus 1 dx. See, one method we can do that, put x square plus x plus 1 is equal to t, differentiating with respect to x on both sides. So we get, so d by dx of x square plus x plus 1, which is equal to dt by dx. So we know that the derivative of x square is like x power n. We have the derivative of x power n. So d by dx of x power n is equal to n into x power n minus 1. So that's why the derivative of x square is also, so 2x, and derivative of x, which is 1, derivative of constant we know that 0. So that's why 2x plus 1 is equal to dt by dx. So from this, by the cross multiplication, we get, so 2x plus 1 into dx is equal to dt. 2x plus 1 into dx is equal to dt. So now what is the here given integral? Therefore I is equal to integral 2x plus 1 by x square plus x plus 1 dx. So here 2x plus 1 dx is replaced by, so here, so dt, and x square plus x plus 1 is t. So that's why finally we can write here, so therefore I is equal to integral, so x square plus x plus 1 is already we have taken t. So that's why this is 1 by t, and here 2x plus 1 dx is dt. So which is 1 by t dt. So we know that, So integral 1 by x dx, so which is equal to, so log mod x, so plus c, we have the integral. So same like that, I is equal to, so which is also log mod t plus c. So finally I is equal to log mod, so t is what we have here, we have taken x square plus x plus 1, so plus c. So this is the solution of the given integral. Or else we can do in other way, or so simply we can do that here. So given integral is I is equal to integral 2x plus 1 by x square plus x plus 1 dx here. If you take, let f of x is equal to here x square plus x plus 1. So if you differentiate, we know here already the derivative of x square plus x plus 1 is 2x plus 1. So if you differentiate, we get f dash x is equal to 2x plus 1. So we have the x square derivative is 2x, x derivative is 1. So we have here one more formula, integral, so f dash x by f of x dx, so which is can be written as log mod f of x plus c. So like this, we can apply this formula for this here. Integral 2x plus 1 by x square plus x plus 1 dx means numerator is here f dash x and denominator is x square plus x plus 1, which is f of x. So therefore using this formula we can write I is equal to here directly log mod f of x. What is f of x here? X square plus x plus 1, so 5 plus c. So like this also we can find the given function integral. So in this video we are going to discuss integration 2 marks, pyqs. Question is evaluate integral 1 by x plus 3 into root over x plus 2 dx. This is very important problem, many times repeated in the final examinations. So now let I is equal to integral 1 by x plus 3 into root over x plus 2 dx. This is also can be solved by using the substitution method. Now I am taking here, put root x plus 2 is equal to t. Now squaring on both sides, we get, so x plus 2 is equal to t square. So differentiating with respect to x on both sides, so we get, so d by dx of x plus 2 is equal to d by dx of t square. D by dx of t square. So with respect to x, x derivative is 1, so and constant derivative is 0. So that's why d by dx of x is 1 and d by dx of 2 is 0. So which is equal to, here with respect to x, t square derivative is 2t into again d by dx of t. So finally we get, so 1 is equal to 2t into dt by dx. So by the cross multiplication, 1 means what? 1 by 1. By the cross multiplication, we get dx is equal to 2t dt. So in the given integral, wherever dx is there, the dx is replaced by 2t dt. So now once again to find the integral of the given function, taking the given integral I is equal to, so integral 1 by x plus 3 into root x plus 2, so dx. Now here to solve the further, what I am doing is this x plus 3 is also writing in terms of x plus 2. It can be written as x plus 2 plus 1. 3 can be written as x plus 2 plus 1 into root over x plus 2 into dx. So now I is equal to integral 1 by, observe here, x plus 2 is equal to, we know that t square. So it can be written as t square plus 1, t square plus 1, and root x plus 2 we have here. This root x plus 2 is replaced by t. So and dx, see we have dx is equal to 2t dt. So that's why here dx is replaced by, so 2t dt into 2t dt. So observe here in the numerator and denominator, t gets cancelled. Now 2 is constant, so that's why, so 2 into integral, it can be written as 1 by 1 plus t square dt. So now, which is in the form of this 1 by 1 plus t square integral is in the form of integral 1 by 1 plus x square dx. So, which is, we know that standard form is tan inverse x plus c. The integral of 1 by 1 plus x square dx is tan inverse x plus c. So, that's why here, so this integral 1 by 1 plus t square is like integral 1 by 1 plus x square dx. So, which is also can be written as 2 into tan inverse t plus c. Finally, what we have taken here t is root x plus 2. So that's why here t is replaced by root x plus 2. So finally we get the integral of the given function is I is equal to 2 into tan inverse of root x plus 2 plus c. Like this we can find the given integral. So in this video we are going to discuss integration 2 marks. Question is evaluate integral e power tan inverse x by 1 plus x square dx. So to find the integral of this function, let I is equal to integral e power tan inverse x whole divided by 1 plus x square dx. So by using substitution method, we can find the integral of this function. So put tan inverse x is equal to t. Now differentiating with respect to x on both sides, So now d by dx of tan inverse x, so which is equal to, this is dt by dx. We know that the derivative of tan inverse x is 1 by 1 plus x square. So derivative of tan inverse x is 1 by 1 plus x square is equal to dt by dx. So by the cross multiplication we get here, so 1 by 1 plus x square dx which is equal to dt. So now take the given integral. Once again take the given integral to find the solution. So therefore I is equal to, we have integral e power tan inverse x whole divided by 1 plus x square dx. So it also can be written as I is equal to integral e power tan inverse x into 1 by 1 plus x square dx. Now observe here, this 1 by 1 plus x square dx can be written as, this entire thing can be written as, so dt here. So that's why integral e power tan inverse x, we have taken t here. So that's why e power t into this is dt. So I is equal to, why? Because we know that here already 1 by 1 plus x square, 1 by 1 plus x square dx is equal to dt. So that's why 1 by 1 plus x square dx is replaced by dt. So now tan inverse x is replaced by t. Finally the given integral I is equal to integral e power t dt. So it is like integral e power x dx. So e power x dx is, we know that integral of e power x is e power x plus c. So that's why I is equal to, we can write e power t plus c. Finally here what we have taken t is tan inverse x. So t is replaced by tan inverse x. So that's why e power tan inverse x plus c, this is the final solution of the given integral. In this video we are going to discuss integration 2 marks. pyqs. Question is evaluate integral e power x into 1 plus x log x by x into dx. So we have to find the integral of this function. In the solution, let I is equal to integral e power x into 1 plus x log x whole divided by x dx. Now here I is equal to integral e power x into, split this x for both the values, it can be written as 1 by x plus x log x by x dx. Now here I is equal to integral e power x into 1 by x plus, so in the numerator and denominator x gets cancelled, so log x dx. Now let f of x is equal to log x. We know that the derivative of log x, that is f dash x, is equal to 1 by x. So why? Because here we have the formula integral e power x into f of x plus f dash x, so dx, so which is equal to e power x into f of x plus c. We have the standard formula integral e power x into f of x plus f dash x, that means derivative of f of x dx is equal to e power x into f of x plus c. Now observe here, suppose if you say this is 1, from 1, so what we have here, I is equal to, so integral e power x into 1 by x plus log x dx. Compare the formula here, then e power x, so in place of f of x we have log x. Why? Because here derivative of log x, that is 1 by x, so that's why here f of x is log x and f dash x is 1 by x, so that's why which is equal to e power x into, this is e power x into f of x. What is f of x here? Log x. So that's why e power x into log x plus c. So therefore finally we can write the integral of the given function I is equal to e power x into log x plus c. So like this we can find the integral of the given function. So in this video we are going to discuss integration 2 marks questions. The question is evaluate integral of 1 by 1 minus x square plus 1 by 1 plus x square dx. So how to find the integral of this function? This is also given in the previous years, very important problem. Now you take that I is equal to integral of 1 by 1 minus x square plus 1 by 1 plus x square dx. Now operating the integral for both the functions, integral 1 by 1 minus x square dx plus integral 1 by 1 plus x square dx. So just simply you have to remember here, so the standard form integral 1 by 1 minus x square dx is equal to, we have the standard form tan h inverse x plus c, and also so the standard form for integral 1 by 1 plus x square dx, which is equal to tan inverse x plus c. So if you remember the formula for integral 1 by 1 minus x square dx is equal to tan h inverse x plus c, and integral 1 by 1 plus x square dx is equal to tan inverse x plus c. Now simply you can operate that formula, you can apply that formula here. So integral 1 by 1 minus x square dx so can be replaced, that means you can write it as tan h inverse x plus integral 1 by 1 plus x square dx, so which is tan inverse x. Finally, after completion of the integral, we can keep the integral constant, that is c. So we get the solution of a given integral is I is equal to tan h inverse x plus tan inverse x plus c. So in this video we are going to discuss integration 2 marks pyqs. The question is, so evaluate integral x cube minus 2x square plus 3 dx. It is also very important, so which is also given in the final examinations. So previous years, how to find the integral of this function. So here taking let I is equal to integral x cube minus 2x square plus 3 dx. So now it can be written as I is equal to, so operating the integral for every term, that is integral x cube dx minus 2 into integral x square dx plus, so 3 into 3 means actually 3 into 1, so that's why 3 into integral 1 dx. So here this is based on completely one of the standard form of the formula, that is integral x power n dx. We have x power n plus 1 by n plus 1 plus c. Now see here in this case, when you take the integral x cube dx, in this case n is 3, so that's why I is equal to, here it becomes x power 3 plus 1 by 3 plus 1 minus 2 into, here if you take integral x square, so that is here n is equal to 2, so that's why it can be written as x power, so 2 plus 1 by 2 plus 1, this is as per this formula, and plus 3 into integral 1 dx. Integral 1 dx, which is equal to x plus c. We know the standard form, that is integral 1 dx, so which is x, so plus c here, 3 into x plus. So finally it can be written as x power 4 by 4 minus 2 into, so this is x power 3 by 3 and plus 3x plus c. It is also can be written as I is equal to x power 4 by 4 minus 2 by 3 into x cube, so plus 3x plus c, which is the final solution of the given function. Now in this video we are going to discuss integration 2 marks pyqs. Question is, evaluate integral e power x into 1 plus x by cos square of x e power x, that means x into e power x dx. Now how to find the integral of this function? So this is also very important problem, many times given in the examinations. Now to find the integral of this function, let I is equal to integral e power x into 1 plus x by cos square of x into e power x dx. Now to find the integral of this function, what I am doing is, so taking x into e power x is equal to a substitution t. Now differentiating with respect to x on both sides, differentiating with respect to x on both sides. Now d by dx of x into e power x is equal to dt by dx. So now if you observe here, so this x into e power x is like, so u is x and v is e power x. So we have the formula. Suppose two functions are there in the product. By product rule, we can do the derivative of those two functions like this. Suppose d by dx of u into v is equal to u into derivative of v, u into derivative of v with respect to x plus v into derivative of u with respect to x. Now same like that, here what we have taken u is x and v is e power x. So now which implies if you apply the formula u into, that is x into, so derivative of, that is d by dx of e power x plus v into, that is e power x into d by dx of u, that is x, is equal to, so right hand side we have dt by dx. Now again we know the derivative of e power x. We know the derivative of e power x is what? E power x. So now x into derivative of e power x is e power x plus e power x into, so derivative of x is 1, so which is equal to dt by dx. See, we know that clearly derivative of d by dx of e power x, which is equal to e power x, and derivative of x with respect to x, that is 1. So as per this formula, we can write it like this. So x into derivative of e power x is e power x plus e power x into derivative of x is 1. See, observe here, in both the terms, left hand side, we have clearly e power x is common. So now if you take the e power x common here, we get, so e power x into x plus 1, so is equal to dt by dx. So here if you take e power x common, so we get e power x into x plus 1 is equal to dt by dx. By the cross multiplication, we get, so here e power x into x plus 1, so dx is equal to, we get dt by the cross multiplication. E power x into x plus 1 into dx is equal to dt, we get by the cross multiplication. So now taking the given integral, this is, suppose if you take 1, so now from 1, so what is, we have 1, I is equal to integral e power x into 1 plus x whole divided by cos square of x into e power x dx. See here, we have taken x e power x is equal to t, we get finally here e power x into x plus 1 into dx is equal to dt. So that's why this also can be written as integral 1 by cos square of x into e power x into, so this e power x into 1 plus x dx also can be written. It can be written as 1 by cos square of x into e power x into e power x into 1 plus x dx. See here we have e power x into x plus 1 dx is equal to dt, and x e power x is equal to, here we have t. So that's why the function becomes integral 1 by cos square t, this is a x e power x is t, and e power x into x plus 1 dx is equal to, we have dt. So that's why this is replaced by dt. So now clearly the function I is equal to integral secant square t, 1 by cos is nothing but secant. So that's why secant square t dt. So now we have actually integral secant square x dx, so which is equal to tan x plus c. So as per this standard form, we can write it as, so secant square t can be written as, so here tan t plus c. So finally we get I is equal to tan of, what is t here? We have taken t is x into e power x. So t is replaced by x into e power x. So plus c. So finally we get the integral of the given function is I is equal to tan of x into e power x plus c. So in this video we are going to discuss integration 2 marks, pyqs, previous year's questions. Question is evaluate integral root over 16 minus 25 x square dx. So how to evaluate this is? So let I is equal to integral root over 16 minus 25 x square dx. So in this I is equal to integral root over, so here taking 5 common, 25 common, suppose if you take here, so if you take 25 common within the root, then you get here 25 into, this can be written as 16 by 25 minus here x square dx. So why to take the 25 common, that you know. So now here root over 25. So root 25 is equal to, we know that 5, which is a constant. So it can be written as 5 into integral. So root over, so 16 by 25 can be written as 4 by 5 whole square minus, so x square can be written as x whole square dx. So now observe here, which is in the form of one of the standard forms, we have integral, so root over a square minus x square dx. Integral root over a square minus x square dx. What is a here? 4 by 5 is a, clearly x is x1. So we have x by 2 into root over a square minus x square, a square minus x square, and here place a square by 2 into sine inverse of x by a plus c. This is the standard form. So now this root over 4 by 5 whole square minus x square, which is in the form of root over a square minus x square. So that's why I is equal to here 5 into, so now x by 2, x is what x only, so that's why x by 2 into root over, so a square minus x square means here, so 4 by 5 whole square minus x whole square, and plus, so a square by 2, so what is a here? A is 4 by 5 whole square by 2 into sine inverse of, so what is x here? X is x only, by here a is 4 by 5, clearly we know that, so plus c, plus c. So now here clearly it can be written as I is equal to, so 5 into, so this is x by 2 into root over, this is 16 by 25 minus x square, so plus here a square by 2, that means 16 by 25 by 2, so into sine inverse of, here x by 4 by 5 is nothing but, so 5x by 4 plus c. So which is also can be written as, now I is equal to, here 5 into, so this is x by 2 into, so this is root over, so root over 16 minus 25 x square by 25 plus here, so 16 by, so 25 by 2, it becomes 16 by 2 into 25, 2 into 25 into sine inverse of, 5x by 4, 5x by 4 and plus c. So now which is also can be written as I is equal to 5 into, so x by 2 into root over 16 minus 25 x square whole divided by root 25 is nothing but 5. So and here, so plus, so this is it, 8 times we can cancel, so 8 by 25 into sine inverse of 5x by 4, 5x by 4 plus c. So now again if you multiply this inside the value with 5, so we get, so I is equal to here x by 2 into root over, so 16 minus 25 x square. If you multiply with 5, 5 gets cancelled for the first term. For next term, if you multiply by 5, so we get here 5 5s are 25, so that's why 8 by 5, 5 into 8 by 25 is nothing but 8 by 5 into sine inverse of 5x by 4 plus c, so which is the final solution of the given integral. Like this we can prove the integral of the given function. So in this video we are going to discuss integration 2 marks pyqs. The question is evaluate integral secant square x into cosecant square x dx. This is also given in the previous examinations. So now in the solution let I is equal to integral secant square x into cosecant square x, so dx. So now here to solve this one we have the identity here. So cosecant square x is equal to, cosecant square x is equal to 1 plus cot square x. So that's why here cosecant square x is replaced by, so 1 plus cot square x, 1 plus cot square x, so into dx. So now I is equal to integral, if you multiply with this, so these two terms multiplying by secant square x, now we get secant square x into 1 secant square x plus secant square x into cot square x, secant square x into cot square x, so into dx. So now here I is equal to integral, so now secant square x plus, so we know that secant is 1 by cos, this secant square x can be written as, so 1 by cos square x, and again here cot also we know that cos by sine, so that's why which is cos square x by sine square x, so dx. Now if you write like this, observe the numerator and denominator cos square x gets cancelled. So now the function becomes, so I is equal to integral secant square x plus here 1 by sine square x, 1 by sine square x into dx. So now I is equal to here, it can be written as I is equal to, so this is integral, so secant square x plus, we know that 1 by sine is cosecant, so that's why this is can be written as 1 by sine square x can be written as cosecant square x dx. Now further it also can be written as, so integral secant square x dx and plus integral cosecant square x dx. But we know the standard form of the integrals, so that is integral secant square x dx, so which is equal to, we know that tan x plus c, and integral cosecant square x dx, so which is, we know that minus cot x plus c. So that's why here these are the standard forms you must be remember. So to get the solution of this, so that's why I is equal to integral secant square x is replaced by, so as per the formula tan x, and plus integral cosecant square x is replaced by, so minus cot x as per the standard form. Finally integral constant is plus c, so we get the solution I is equal to now tan x minus cot x plus c. So like this we can find the integral of the given function. So in this video we are going to discuss integration 2 marks pyqs, previous year's questions. This is also given in the previous examinations. Question is evaluate integral 1 by cos square x plus sine 2x dx. So now in the solution, let I is equal to integral 1 by cos square x plus sine 2x dx. So now here I is equal to integral numerator and denominator divide by cos square x. Numerator and denominator divide by cos square x. So now here 1 by cos square x and this is cos square x plus sine 2x whole divided by cos square x dx. So here what I did, dividing numerator and denominator by cos square x. Numerator is 1, so 1 by cos square x, and denominator is we have cos square x plus sine 2x, which is also divided by cos square x. Now further it can be written as, see we know that 1 by cos is secant, so that's why integral 1 by cos square x can be written as secant square x, and here split the denominator, it can be written as cos square x by cos square x plus sine 2x by cos square x, so dx. Sine 2x by cos square x dx. Now here cos square x gets cancelled. So I is equal to integral secant square x whole divided by, so here 1 plus and sine 2x here. So sine 2x can be written as, so 2 sine x cos x, 2 sine x cos x whole divided by, so cos square x. So we know that sine 2x is it. Suppose sine 2 theta, we have sine 2 theta is equal to, so 2 sine theta cos theta. So as per this formula, we can write sine 2x as 2 sine x cos x by cos square x. Here cos x gets cancelled. We get I is equal to integral. So this is secant square x whole divided by 1 plus here 2 into this is sin x by cos x, sin x by cos x dx. Now further here we know that sin x by cos x is nothing but tan x. So that's why here I is equal to integral secant square x whole divided by, so here 1 plus, so 2 sin x by cos x here, so which can be written as tan x. Sin x by cos x can be written as tan x dx. Now by using substitution we can solve this. So now put tan x is equal to, take tan x is equal to t, differentiating with respect to x on both sides, we get, so d by dx of tan x, so is equal to here dt by dx. So d by dx of tan x is equal to dt by dx. Now we know that tan x derivative is what? Secant square x. So now secant square x is equal to, so dt by dx, secant square x is equal to dt by dx. So now here by the cross multiplication we get secant square x dx is equal to dt. Now in the given integral, that means now we say this is 1. So now therefore from 1, so what we have here, so from 1, so I is equal to integral, so secant square x, so by 1 plus 2 tan x, so dx. Now the secant square x dx can be replaced by dt, and here this tan x is replaced by t. So secant square x dx is replaced by dt, and here tan x is replaced by t. So now which can be written as integral, so 1 by 1 plus 2t here, tan x is t and secant square x dx is dt. Now what I am doing is here multiplying numerator and denominator by 2 suppose. So now it becomes 1 by 2 into integral, so 2 by 1 plus 2t dt. 1 plus 2t dt. See, observe here y2 multiply numerator and denominator by 2. Now suppose if you take, let f of t here, f of t is equal to 1 plus 2t. If you differentiate it, you get f dash of t is equal to, here one derivative is 0 and 2t derivative with respect to t 2 1. Now if you observe here, so this integral is in the form of like integral, so f dash of t by f of t dt. Actually we have in terms of x, f dash of x by f of x dx, but here function is in terms of t, so that's why f dash of t by integral f dash of t by f of t dt. So it can be written as, we have the formula log mod f of t plus c. So that's why which is f of t here, this is f of t, here this is f of t, and which is f dash of t, 2 is clearly I wrote here. F of t is equal to 1 plus 2t, f dash of t is equal to 2. So that's why as per this formula, it can be written as I is equal to finally 1 by 2 into, so log mod f of t, that is log mod, so what is f of t here, 1 plus 2t, so that's why this is log mod 1 plus 2t plus c. So finally this t is replaced by, already we have taken t is equal to here tan x, so that's why finally solution can be written as 1 by 2 into log mod 1 plus 2 tan x, log mod 2 tan x plus c. So like this we can find the integral of the given function.